Hello everybody and welcome back to the Tank Encyclopedia's YouTube channel. My name is Conavark and today I'm going to be telling you about one of my favorite tanks, the Maus. It is impossible to consider the Maus and not be impressed by the machine as a feat of engineering. At 188 tons, it is the heaviest operational tank ever made by any nation at any time in any war, and was made despite the shortages of raw materials, industrial capacity, and manpower at the time in Nazi Germany. Yet, despite the impressive achievement of making this rolling behemoth, the vehicle stands as a testimony to the total waste taking place in the German industry and the inefficiencies inherent in the way in which tank development was carried out. By the time the Maus was finished in 1945, it was a boondoggle. No amount of awe at the size, weight, firepower, or armor on this beast could disguise the incredible waste of resources it accounted for, nor could it make any difference in the outcome of the war. The Maus, as a weapon, was simply useless, yet the lessons learned from its development did find use in other programs, and the very existence of such an enormous machine has inevitably drawn a significant amount of attention. Drawing both awe and fascination in equal measure, the Maus is a complex tank with a lengthy development. Following the invasion of the Soviet Union on 22nd June 1941, the German army had quickly gained huge swaths of territory and destroyed, captured, or killed large quantities of Soviet troops, supplies, and equipment. Yet, despite the success, the German army was unable to deliver a knockout blow against the Soviets or to capture Moscow. By January 1942, with Moscow saved by an increasingly stubborn Soviet defense, it was clear that the conflict on the Eastern Front was going to be very long and very bloody. As Soviet tanks of increasing quality, armor, and firepower started to reach the front lines through 1942, it was clear that in order for German forces to maintain an edge in tank combat, they needed a tank that was bigger, more heavily armored, and better armed than anything that had gone before. There was also a need for a heavy tank capable of assaulting heavily defended enemy positions, and since nothing in the German arsenal in spring 1942 was capable of meeting these requirements, long-term plans were being put in place. The origins of the Maus began around this time, as on 5th March 1942, a directive was issued to Fried Krupp AG of Essen for the development of a new heavy tank in the 100-ton class to replace the previous concept of a 72-ton tank, which originated as a project by Rheinmetall started in 1938. The goal was to have an operational trial vehicle for this 100-ton vehicle in the shortest time possible and to be ready to show it off in the spring of 1943. 2 weeks later, on 21st March, Dr. Ferdinand Porsche was given a separate and independent contract for exactly the same goal, a 100-ton tank. Thereafter, requirements for this 100-ton tank started to fall into line, with demands for a heavy gun and at least one machine gun. The whole machine gun would be eliminated as long as there was a separately controllable machine gun, as this would simplify the design and eliminate the hole in the front armor needed to accept a whole machine gun. By May 1942, however, the 100-ton limit was being seen as too conservative, and a 120-ton limit was permitted with priority placed on achieving the heaviest possible armor and firepower. Speed was not an important factor. Initial drawings were completed on 4th June 1942 by Porsche's designers at Zuffenhausen. The project was named Sonderfahrzeug 4, but identified as the Project Type 205. Completed drawings from Porsche for this 120-ton vehicle mounting a 15-centimeter gun were ready by 23 June 1942 and approved by Hitler. As an indication to the heavy armor proposed, the hull floor alone was to be 100 millimeters thick, the same thickness as the front armor that would be used on the Tiger I. Hitler approved the design, selecting a 10.5 centimeter L-70 gun and discounting the idea for a secondary turret with a 7.5 centimeter gun, as the tank was to be supported by other tanks. The priorities for the design had changed. In May, these had the armor on top, followed by firepower and speed in this order. But in June, this changed to firepower, followed by speed and armor. A contract was then issued on 17th July 1942 to Krupp to design a turret for this new tank under the name Panzerkampfwagen VIII. This new turret, weighing 57 tons, was to be incredibly heavily armored, with armor 250 millimeters thick at the front, 200 millimeters thick on the sides, and 80 millimeters thick on the roof, and was to mount 2 guns. Design work then proceeded on, taking this enormous turret and firepower and producing them from a conceptual vehicle that could fit within the normal limits of the German rail gauge. From August through September, work at Porsche continued on creating what was inevitably going to be a boxy-shaped vehicle in order to fit within the tight limits of the rail gauge. Combined with the work of Krupp on the turrets, it must have been considered to show significant promise too, as at the end of September, the turret being designed by Krupp was selected to replace the earlier 10.5 cm gun turret on the Löwe program, and thus Krupp received the contract for this too. Between conceptualization in March 1942 and October 1942, it had been fairly plain sailing for both Porsche and Krupp. Despite some general disagreements within the German establishment over a preferred gun or guns for the tank, it had been fairly plain sailing for both Porsche and Krupp. On 5th October, the new design was ready under the name Type 205A and had options for either a 15 cm L37 or for a 12.8 cm gun to work alongside the 7.5 cm KWK L24. The dominant feature of what was little more than an enormous brick with pointed ends fore and aft was the enormous rectangular turret, roughly half the length of the entire tank. The engine was mounted ahead of the center line, but delivered drive to the sprockets at the rear via an electric drive. The entire vehicle was to be mounted on 12 pairs of double road wheels running along a 1 meter wide track, although a pair of 500mm wide tracks were also considered. All told, this Type 205A was going to weigh some 150 tons, and, in keeping with common design practice, was still to retain a front-mounted machine gun in the hull on the right-hand side. Power for this 150-ton vehicle was to be provided by a single 44.5-liter 12-cylinder Daimler-Benz water-cooled diesel delivering 1,000 horsepower at 2,400 RPM. This was connected to an electric generator, which, in turn, delivered the electrical current to a motor on each side of the back, each connected to a 918mm diameter drive sprocket. This arrangement would allow the Type 205A to reach a top speed of 20 km an hour. An alternative engine, the 41.5-liter Type 205-2 Porsche air-cooled diesel, was also shown in October 1942 as an option. This was labeled as Type 205B and could deliver 780 horsepower at 2,000 RPM. A review of the Type 205A and Type 205B Mäuschen took place in November 1942 by the Panzerkampfwagen and resulted in Krupp and Porsche being ordered to make another design with a turret at the back. The result was a 170-ton proposal from Porsche for a rear-turreted version using the same Daimler-Benz 603 water-cooled petrol engine as before, but with the addition of a compressor. It was also to use the electrical transmission taken from the Panzerkampfwagen VI P. Consideration at this time was also given to the production of a Sturmgeschütz version of the rear-turreted Mäuschen, but this was rejected by Oppert Thomal from Waffenprüfungsamt 6, the branch of the German Ordnance Department responsible for motorized vehicle design. When this work was presented to Hitler at the start of December 1942, he was supportive and ordered the production of a trial vehicle to be ready for operation in the summer of 1943, with a production of 5 vehicles each month thereafter, assembled by Krupp. It is important to note that at this time the Porsche design was known as the Maus and the Krupp design as the Tiger Mouse, but a dose of reality was also setting in. From an original 100 tons to maybe, if necessary, 120 tons, the weight had ballooned to 170 tons, and so some weight needed to be stripped off. The easiest way to achieve this was to reduce the amount of steel on the vehicle, which meant reducing the level of protection it offered from 250mm at the front and 200mm at the side to just 225mm and 180mm on the front and sides respectively. With the Krupp-designed Tiger Maus being judged to be the lesser of the two designs, it was terminated in 15th December 1942, with the Porsche design being selected, albeit with significant changes. Further changes to the hull to accommodate the removal of the turret collar and allow for a tunnel for the driver and radio operator at the front to get to the turret without getting out were making the design process difficult. Even as these changes and other minor changes were discussed, a decision was made on production. Hitler met with Albert Speer on 3rd January 1943 and ordered the Maus to be produced between three manufacturers. Porsche would design it, Krupp produced the armored segments, and Alket would assemble these components into a functional tank. Hitler was adamant that the production of the tank should be able to begin by the end of that year and deliver the Mäuschen at a rate of 10 tanks per month. By January 1943, the preliminary ideas for the Mäuschen were out of the way, and a decision was made that the proposal from Porsche, rather than the design from Krupp, was to be selected. Several key design decisions had been made regarding the layout of this tank. Firstly, there will be no hull machine gun at all. It weakened the frontal armor and added another element of complexity to the design. It simply did not need it. Secondly, the idea of a connecting tunnel to link the driver and radio operator at the front to the rest of the crew was abandoned. These men would remain physically isolated from the rest, but connected via intercom. One additional note here is that there was a 20mm thick armored bulkhead between the driving compartments so that, in the unlikely event of that compartment being breached by a shell, the drive system would still be protected. Likewise, in the event of a fire in the engine bay, those men in the front would be protected. A small access hatch in this bulkhead was provided for maintenance purposes. The massive turret was to go at the back with the engine in front of it, the electrical components underneath it, and the motors behind it, while the armor specifications had been decided at the start of January 1943. With that, a full-size wooden model was ordered to be shown at the Panzerkampfwagen on 21st January. Here, under the eagle eye of representatives from Porsche, Alket, Daimler-Benz, Skoda, Waffenprüfungsamt, the Army, and Krupp, various changes were suggested, including larger crew hatches in the hull, a new lighter type of track, a machine gun mounting next to the hull crew hatch, a 100mm thick track guard. In February 1943, the engine for the Maus became the focus of attention. A big tank, after all, required a powerful engine. Maybach had originally been offering Porsche a supercharged V12 engine capable of delivering 1,000 horsepower, but that engine turned out to be a pipe dream and was dropped. As to Porsche's preferred engine, the 36.5-liter Simmering Graz Pauker SLA 16, this was not ready. Instead, Porsche selected a vehicle version of the new DB603 aircraft engine, a 44.5-liter V12 petrol engine known as the MB503A. Fuel injected, this engine could produce 1,200 brake horsepower at 2,300 RPM, but could only deliver 1,080 horsepower of that power due to having to run engine accessories. The alternative engine available was the MB507C, a diesel version of the engine capable of producing up to 1,000 horsepower. The engine was connected to a pair of Siemens direct current dynamos, each producing 400 kilowatts at 2,800 RPM, that were a reverse of the layout in the Ferdinand Elephant. In that vehicle, the dynamo was in the front of the engine. Here, they were behind. The electric drive was selected primarily because it required less development time than a mechanical drive, but also because it made deep forwarding much simpler. A key departure for the Maus from previous German designs was the placement of the final drives at the back of the tank. One thing commonly forgotten, or otherwise not paid attention to, is engine maintenance. There were obviously removable hatches in the roof of the hull, but there was an additional hatch on the floor of the engine room measuring 1,295mm by 216mm in the 50mm armored floor, rather than the 100mm thick floor proposed back in June 1942. All these changes had swollen the weight of the Maus by about 10 tons, mainly as the result of a 3% thickness tolerance on the armor plate and the addition of a Flammenwerferanlage. This 10-ton burden was further increased by additional ammunition stowage demanded by Hitler in May and a Gasschützenlager in June. The goal of the entire project was to create a heavy tank all but immune to enemy fire. The Krupp turret design from 17th July 1942 had armor 250mm thick at the front, with a large cast steel mantlet in front of that. The side armor was to be 200mm thick, and it was to have a roof 80mm thick. By the start of December 1942, the need to shed some weight had brought the suggested turret armor down from 250mm on the front and 200mm on the side to 225mm on the front and 180 on the sides. And, by the end of the month, it was reduced yet further. By the end of December 1942, therefore, the hull armor for the Mäuschen Type 205 was also reduced, down to 200mm on the front. The sides were to be the same thickness as would be used on the Tiger II, with 80mm on the inner hull sides, except that on this vehicle they would have an additional 100mm outer skirt layer over the top. The rear was to be 150mm thick, with the roof of the hull 100mm thick at the front and 50mm thick at the back. Although British measurements in 1945 of a scrap hull say that the space was for a plate 60mm thick. The hull floor had been reduced from 100mm across the full length to just 100mm under the front of the hull and 50mm at the back. In January 1943, the design from Porsche had won out over the design from Krupp, and the armor, the source of a lot of debate and redesign, had been determined. A full-size wooden model of the Maus was ordered, as it was now being known, which combined the Porsche Type 205 hull with the Krupp Maus term. The armor was to remain effectively unchanged from the acceptance in 1943, as any major changes would affect the wheelbase of the tank. In January 1943, though, it was proposed to make the side walls in one piece by simply using one 180mm thick plate and milling out 80mm of the thickness for the bottom half. This would have the advantage of improving protection, as the plate would all be in one piece, but Krupp, the manufacturer of the armored hulls, had a different idea. It wanted 60mm of the armor to be milled out to provide plate 120mm thick over the wheels instead, but this would not be achieved without affecting both the wheelbase and the interface of the armor, which was supposed to be made from softer steel than the exterior armor. Krupp, however, did not give up, as the plan to make the sides in one piece and milling out what would be 4.5 tons of steel from each side plate was not an attractive one from a production point of view, as it was laborious, difficult, and wasteful of steel. Instead, Krupp proposed making it in two pieces, one 80mm thick for the hull side and an outer layer 100mm thick bolted to it. A further suggestion was to abandon the solid side plate altogether and to use a pair of plates. The idea was to not attach them together to be a homogeneous panel of steel, but to space them 30 to 40mm apart on bolts. This, however, would involve a redesign of the tank, and the first Krupp alternative proposal also had been rejected. Making the armor from two separate plates was complex due to the need to ensure they could fit and would reduce the protection from enemy fire due to the weakness of the bolts which might be used. These ideas for changing how the side armor was to be made could not be executed at the time and still keep the production schedule for the Maus on track, but were not abandoned. They, along with another spaced armor plan where the 100mm and 80mm plates were held just 10mm apart, and a plan for the entire side to be just a single 180mm thick panel, were to be subjected to firing trials. These potential improvements were confirmed in April 1943 when Porsche announced that it had improved the suspension system for the Maus so that it no longer relied upon a mounting on the interface of the outer armor skirt. So simple was this solution that the lower section of the side armor could be made thinner and simply welded to the upper section. This was approved as a change for Vanna No. 7 onwards from the total of 120 tanks to be produced. This order was increased to 135 in May 1943. So, the first 6 Maus hulls were planned to be made with a single 180mm thick side plate, which was milled down to 100mm thick on the lower part, but after that, production would be greatly simplified by virtue of the improved suspension design. The side armor would still be 180mm over the upper sides, but the lower part could simply be welded on as the suspension was now connected only by the inner hull of the tank rather than spread to the side skirt. This is a good lesson in how a small design change in one component can deliver a significant improvement in manufacturing. In February 1943, the armor for the Maus was once more under discussion. This meeting, held on the 4th, was not about methods of construction or proposed thicknesses required, but on the material itself. In order to make sure the armor was as good as possible, it was suggested that instead of using the current standard type of armor plate, they should switch to using naval armor plating, which had been made available and was considered to be of better quality than the standard type plate. There was, however, a problem with the plates. Not the weight or material, but the size. In order to be used, these giant slabs of steel would have to be rolled down to 2 meters by 2.3 meters and 200 millimeters thick. Krupp met with representatives of Waffenprüfungsamt VI in the middle of January 1943 to discuss the turret for the tank. Known as the Maus term 12.8 cm, the gun to be used was, unsurprisingly, a 12.8 cm piece. Back in April 1942, the 12.8 cm gun considered was an L50, with additional thought given to using a longer gun of either 60 or 70 calibers. That was reiterated later with thought given to using a 61 caliber long gun firing shaped charge ammunition or types of sabot projectiles. In January 1943, the 12.8 cm selected by Waffenprüfungsamt VI was an L55, as it, combined with the new ammunition, would provide the performance required. Therefore, modifications would need to be made to Krupp's turret design in order to accommodate this longer gun. Even so, there was an option of switching out that gun with a 15 cm L38, and both were to be partnered with a 7.5 cm gun too. January to February 1943 was a time of flux for the turret design. The idea of mounting a flame projector on the turret had been dropped, but in its place were ideas for a 2 cm flak anti-aircraft gun in the front, as well as possibly a new type of rangefinder. Between March and July 1943, 4 types of rangefinders were considered: horizontal, vertical, T-shaped, and V-shaped. The 1.73 meter horizontal type was impossible to use, as the position of the guns prevented it from being installed. A 1 meter vertical type rangefinder would have to be mocked up in wood on the mock-up Maus turret to assess whether or not the loader could even use it. The T-shaped rangefinder was experimental and required a new housing measuring 80 centimeters by 20 centimeters on the turret roof, which would allow the gunner to range and fire on his own, but would also restrict the commander's visibility and would be less accurate at long range. The final type, the V-type rangefinder, was in common use already, but was discounted as it was required to be protected by armor and operable when the tank was buttoned down in combat. Adding to this growth in armament was a growth in protection, as the commander's cupola was significantly up-armored to match the rest of the turret, and the crew hatch was increased to 60 mm thick, with Waffenprüfungsamt insisting on a small petrol/electric generator being added as well. The weight and complexity had increased, although as a plus point, the vision ports and empty cartridge ejection ports planned in the sides of the turret were abandoned. The vision ports would be replaced with new periscopes in the turret roof, and the spent casings could be tossed out of the ammunition hatch. Even with dropping those ports, however, the weight of the Maus term had, by February 1943, crept over the strict 50-ton limit set by Dr. Porsche in order to keep the total vehicle mass to no more than 180 tons. Changes followed through April 1943 with the addition of ports for machine pistols on the side walls on a ball mount. After the full-sized wooden mock-up was shown to Hitler in May 1943, Porsche became very concerned about the shape of the front of the turret, as the inwards curve could lead to shells ricocheting into the roof of the hull. Porsche suggested that they could be obviated by inverting the lower curve to make it curve outwards rather than inwards. That change might add some additional room within what was becoming an increasingly cramped turret, so cramped that when in May 1943 it was decided between Dr. Porsche and the Waffenamt to add a machine gun in the front of the turret, Krupp had to inform them there was not enough room. This was not the only design change proposed by Porsche that was making the life of Krupp difficult, as he had already been asked a couple weeks earlier to stop modifying the turret or making new openings to the base as they were weakening the structure of the tank. Even so, it should be borne in mind that the turret basket of the Maus term remained 55mm thick and the floor plate was 93mm thick. Other problems would remain, however, such as the commander, who had to turn to his left to avoid being hit by the recoil from the 7.5cm gun, and could not sit down when the vehicle was moving or in combat without being hit by the breech of the 12.8cm gun, or recoil guard for the 7.5cm gun. Even standing, the commander had a problem, as he was in the way of the loader when loading the 7.5cm gun, so some shuffling around was needed to operate that gun in combat. Some shuffling of the turret crew positions was implemented in July 1943, with the right side loader moved to the back of the turret, where he could sit just inside the bustle. Combined with the removal of the ammunition loading assist system, space could be freed up within the turret, reducing some complexities associated with the loading system, as well as allowing the loader to freely operate the smoke grenade launchers. The commander would be moved over to the position occupied by the loader, and this simple change got him out of the way of the breech of the 7.5cm gun, as well as allowed him to operate the rangefinder. The gunner could also be moved, as his legs were in an awkward position. Moving him back to the position occupied by the left side loader removed this problem and allowed him to not only operate the turret rotation mechanisms, but also the machine gun in the front of the turret. That loader was simply moved to the rear of the turret with the other loader. This crew shuffling was simply a result of too much crammed into the turret, which, although massive on the outside, was significantly smaller on the inside, as the majority of the space was occupied by the breeches of the guns and their associated ammunition. Yet, despite these difficulties, there seemingly was no discussion of the obvious solution: remove the 7.5cm gun. At the time, as Porsche was suggesting the front curve being inverted, he also had the idea of adding a 3.7cm anti-aircraft gun in an anti-aircraft turret on top of the primary turret, capable of 360-degree traverse, seemingly in contradiction to the fact that the turret was already at or just over the 50-ton limit Porsche had personally imposed that February. Despite the difficulties with the turret design, and ignoring Dr. Porsche's concerns over the front curve and his less than stellar idea for an AA gun turret on top of the primary turret, a mock-up was ready by July 1943. As development and discussions over the fabrication of the armor for the hull were taking place with the newly designed suspension in January 1943, the work on the turret had also progressed. Krupp, the armor manufacturer for the turret and hull, was issued a contract for a single blank turret and 2 hulls for firing trials. These 2 hulls were not only testing the resistance of the plates to attack, but also the strength of the welds joining what was to be the thickest armor ever mounted on a tank at that time. The standard method of fastening heavy plates together involved cutting interlocking joints in them and then welding over these joints. Other methods included simple welding of one plate to another, and the supplementing of welded seams with a bolted joint piece that could be then over-welded, as was done on the side holes of the Tiger I. For the Maus, however, boring holes for a bolted support plate was not practical, and the joining of the armor plates had to rely on welds supported by pins instead. Hull number 1 was to have the interlocking parts of the armor plating cut by means of being milled out, whereas the second hull for firing trials was to have these sections cut out by means of a flame torch. Cutting by means of the torch was faster and easier than milling out large pieces of heavy armor plate, but was considered to produce an inferior product than milling due to the accuracy of the surface a milled cut would produce. A decision on which method was to be used would not be made until after the firing trials had been completed at Hillersleben in June 1943. Regardless of which method of cutting was to be used, the interlocking sections were to be supported by the use of 100mm diameter connecting pins between these plates. The joint and pins would then be welded together, with the pins providing additional strength to the joint. These pins were important to the construction of the hull to support the welds, but were an additional burden on construction as they had to be bored out and were also considered to marginally weaken the overall armor protection where they were used. Their use was essential to the hull fabrication process, but to reduce any effect on weakening the armor, they were reduced after June 1943 to just 80mm in diameter. Thank you all very much for watching this first part of the Tank Encyclopedia's Maus series. I have been Cone of Arc. Please don't forget to leave a like and subscribe to the Tank Encyclopedia YouTube channel. I will see you in the next part of this series.